Hi, Friday math people. Algebra 2 students. Today you're going to be doing investigation 2, solving parametric equations. There is some activity work in the book, page 143 and following. So after just introducing the idea, we're going to go back into the book. I'll do some of it with you on my calculator, and then I'll leave you guys the rest to do on your own. You guys have the advantage, if, well, it depends on which class this is that watches this someday in history, future you or the future me, or both, whatever. That if you've taken some physics, we've already played around with parametric equations already. So you already know how to get to them by changing the mode, and you know a little bit about how we've had to change the domain and the range in order to see the picture and trace it out, right? To see that you have a time component as well as an x and a y position. So today we're going to play around with that, maybe have some different types of equations, but we'll show you how you can actually even go back and forth between function and parametric. The advantages of parametric being that we can see the position of something at any point in time in both the x and the y direction. So you need your book, you're going to need your calculator, and yeah, you probably need some graph paper as well, because you're going to have to make charts, and you're going to have to maybe do a graph or something of some of the business here in investigation 2. So find your book, open up to page 143, and then follow along on your calculator as I move mine. I'm going to move it after I pause so that you don't get motion sickness. Okay, now that we're in position, let us begin. I suppose you know that you're going to need to change your mode from function mode to parametric mode. So you might as well go ahead and do that. And then just kind of wait here as we begin solving parametric equations. The first equation situation that they describe here in the book is house painting. That the person charges 30 bucks per hour to do their painting. Okay, so there's a this is going to be like a profit thing in terms of time. I'm going to put a P of T here. So depending on how much time I have will determine what my profit is going to be. Second, it says on average she paints 200 square feet an hour. So this would be an area thing in terms of time. We got two things there that depend on time at the same time. Profit and the amount of work that got done. So what the book does, it says, well, we're going to treat this one like it's x and this one like it's y. We would put our profit, suppose here. Oh, no, they're going to put the area painted here, and they're going to put the profit. I guess this is square feet, right? Here, and we're going to graph that at any point on the graph, it would tell us that after 3 seconds, or after 10 hours, or after 2 days, whatever it is, that she's painted this much and she's made this much. And we'll see those two things at the same time. So how are they going to do that? Well, they're going to say that x is 200t and y equals 30t. This could be done on our regular graphing, but we would have to do some combining of these two equations into one equation. And I'll show you really quickly the way that you would do that. And then we'll go ahead and we'll let the calculator show us the picture in our regular format. I'm going to take this first equation and solve it for t. So that's going to involve me dividing both sides by 200. T would equal x over 200. I'm going to take that value for t, I'm going to plug it in to this equation. I'm going to have 30 times what t is equal to, x over 200. So if I do the math here, 10 divided by 10 will have 3x over 20 being our function. Y equals 3x over 20. I'm going to put that in my calculator for now. I'm going to switch back to function mode, and I'm going to put in that function right there of 3x over 20. Okay, 3x over 20 being equivalent to what we got here. And I'm going to set my window to something similar to what we got here. The question asks about, 7 hours. So I'm going to go from like 0 to 20 by 1 hour at a time. And my y scale, everything's going to be positive, so I'll go from 0 to, I don't know, it's going to have to be a big number. Oh no, I got to have x that's really big. Okay, x will go from like 0 to 1,000. And y will go from 0 to 200. So I'll set up my regular function window like this. Now I kind of am interested what the graph looks like, so I'll just, oh snap, I did something wrong here. I have something that's too big. Okay, 0 to 100 by hundreds, that's stupid. There's my problem. 0 to 1,000 by 100s, and 0 to 200 by 10s. Okay, here we go. Now it says when I do it in regular mode, it looks like it's a straight line. X is equal to the amount of area that I've covered, and Y is equal to my profit. So if I trace along the line, well, I had right here at 500. Once I've painted 500 square feet of wall, I should have made 75 bucks. That's what's got there at the bottom when I hit the trace button. Okay, but I want to do it in the other one so that I can see it kind of all at once. And so that's what we're going to do here. We're going to switch it over, and we'll get a different kind of profit area, and it'll indicate along the way t equals a certain number of hours. So x1t is going to be, this is still all of my physics stuff, x1t is going to be 200t, and y1t is going to be 30. So now we know what these things are. The first one is helping us determine how much painting gets done, and the second one is determining how much money we're going to make. Now double check, I got to fix this window. No, we're okay. All the other stuff is the same, and the only thing that's new now is time. And the chart you're going to have to complete only goes out to like 5 hours, so this is plenty of space. Maybe I'll only go to like 6. And we'll go by 0.1 steps, so get the picture drawn. So now when I do it, it looks very similar to the other graph, right? It went fast. But when I trace now, I have, you can see on the bottom of the screen, we've got x, y, and t. So after 0 hours, t is 0. After 0 hours, I've painted nothing and I've made no money. And then we'll go up to 1 hour. At 1 hour, I should have painted 200 square feet and made 30 bucks. You can see then after 2 hours, I've painted 400 square feet and have made 60 bucks. Etc. Right? 600 square feet, 90 bucks. And it's a line. On the bottom, of course, on the X scale, we've got square feet of painting. And on the Y scale, we've got dollars earned for profit. So, number 1 says, suppose the painter worked for 7 hours. Uh-oh. I gotta go out to at least 7. So go down to 8. And I'm going to trace it and type in 7. T equals 7. And it'll put me right at that place. It'll say after 7 hours, you've painted 1,400 square feet and you have made 210 bucks. How many square feet? 1,400. How much did she earn? $210. There it is. All we did was we gave it the equations, the x1 and the y1 equations there in terms of time, and it's thinking about both of those things at the same time. Number 2 on in the book wants us to make a table. They've got t and a set of given things, 1, 0, 1, 2, 3, 4, and 5. And then they've got x in square feet, and they've got y in profit. So if we want to do it this way, tracing would be a little clunky. And so what might be better, and I probably didn't give myself enough room here, would be to make a table. So we know that we can set a table here by go second window. And let's start our table at 0 because our chart starts at t equals 0. And we're going to go up by 1s. I'm going to do it automatically here. This is ready to fill in this chart then. And when I go second table, you see that I get 3 columns. The first column is time, 0, 1, 2, 3, 4, 5. And then we've got x's. And if I get to focus here, focus. There we go. Our x's go 0, 200, 400, 600, 800, 1,000. 0, 200, 400, 600, 800, and 1,000 square feet of painting. And then we look at the last column, and the last column is money. 0, 30, 60, 90, 120. 0, 30, 60, 90, 120, and 150 bucks. We can then look out and see if she worked for 10 hours, she paid 2,000 square feet, and would get paid 300 bucks. So this generates a bunch of sets of numbers, and that's how everything's related. They've already defined x and y, square feet, and money. So that's 2. 3, model. Use the table to write 6 xy coordinate pairs. Do not use the t value. Graph and connect the points. So we've got, here's a bunch of ordered pairs. Now all we got to do is draw a picture with, I guess they said to write 6 of them, 1, 2, 3, 4, 5, 6. We're going to use these 6 right here, and we're going to need some graph paper. And you're going to have to make a scale for that graph. And I'm trying to find something that I can use here that would work. Just would use, it's on the back of my number line. Something like this, right? Except instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, my x is square feet. So maybe this ought to be, 100 and 200 and 300 square feet. Let's just imagine that all these are like hundreds of feet, okay? And over here, my profit, these probably should be, I'm going to run out of room, right? Because it makes 150 bucks. I could do this, but like I said, I'm going to run out of space. Do all these dollar amounts. So all you got to do is you got to transfer this stuff here. We got the point 0, 0. We got the point 200. That would be this right here, 230. So there's a point. Then we'd have 460. We keep going until we've got 6 of these. 600 goes with 70. Wait a second. Oh, that's a 90. Sorry. 600 goes with 90. And then I'm going to run off the screen. So I start connecting the dots, and I saw on both this graph and on this graph, and if I went and switched my mode back to function mode, on this graph, all of them are straight lines. My scale's a little different on the calculator screen than it is here, but we are able to show it as a graph. And so if we only work for 4.5 hours, we could kind of make a prediction of how much money I'd be making. 4.5 hours. Okay, so that's what a parametric equation is. It's when we have a third parameter, and typically the t stands for time. How two things are changing in respect to time. In the book number 5, there on page 143, just asks you to push the buttons in the right order, but basically they want you to do what we just did. Remember, you have to fiddle. Sometimes you're going to have to fiddle with the window to get it to do, to be able to see the picture that you're graphing. And we're going to put our x's and our y equations in there. On page 144, the next question is about golfing. And so they give us, a golfer hits his first shot on a hole. When the golf ball leaves the club, it travels 120 feet per second horizontally, 96 feet per second vertically. And these will probably look familiar to you. They want us to have, for the first equation, 120t. And the second equation, negative 16t squared. The t can be accessed by pushing the xt theta n button. Since we're in parametric mode, t will pop up. Plus 96t. The reason why this should look familiar to you is because this is like what we did in physics. They use, instead of using negative 4.9 like we did in physics class, they're using negative 16 because they're going to be doing the things in feet per second squared. They're going to be doing acceleration due to gravity as, negative 32 feet per second squared. So 1/2 gravity delta t squared, that equation, for giving us the change in distance, g is negative 32, so that gives us 1/2 times negative 32 is negative 16, and then we get our time squared. So that's where that equation comes from. The other part of it is the vertical component of the trajectory. That is, they're hitting the golf ball this way. We break that down into components. 120, whatever it is, feet per second is going this way, and 96 feet per second going vertically. Now they're hitting it this way, but they've broken it down into components and included those components in the equation there. So once we kind of fiddle with our, window, we'll be ready to go to view it or to complete the table or whatever it is that we need to do. Time's going to start at 0. It's in the air for at least 6 seconds, so this is still a good measurement. I really only need it at every second, though it'll look kind of boxy when I do that. X has got to start at 0. You can't hit it really super far, like 300, 400 yards is the longest that you're going to have on a hole. So let's put that at max like 1,000. Let's go by hundreds. Oh, oops, I did this wrong. 0, 1,000, 100. The Y minimum would also be 0, and then it's not going to go super high. It's maybe going to go 150 feet high. And a scale of 10 would be good for this particular problem. So let's see what happens. Pressing graph, we get a bumpy parabola, and that makes sense. That would be the motion of a golf ball. and we can trace it and see where it is at different times. So you can either fill in the chart, the table there, t, x, and y, by tracing it at these different places, or you can make a table, right? And it'll give us all three. It'll give us time, and then in the x direction, and our distance in the y direction. And we can see there that it's hit the ground there after 6 seconds. It's not going, and this would be if it keeps drilling through the ground. So we only need 0 through 6 to fill the thing in. So the graphing calculator would help you come up with a picture. I might want to change this to make it a little bit smoother, make that parabola, but you've got the trace button available to you where you can say t, x, and y. And you scroll to t is 1, t is 2, t is 3, t is 4, 5, and 6. There we go. At 6, it's gone 720 feet in the x direction, and it's hit the ground in the vertical direction. Me again. You know, I never really realized, it's only when there's a camera on you that you realize how bald you are. Well, I mean, how bald I am. You guys aren't bald. So your work is to do the exact same thing, just with some different equations. You'll be doing the investigation practice there. Investigation, this is what, investigation 2. Again, you're going to need some graph paper, so you need to actually graph the thing, draw the charts out. So graph paper will be really good. And page 145, page 145, numbers A through K. And that's it. Investigation 2, solving parametric equations. Practice problems on 145, numbers A through K. Hope you have a nice break. Don't eat too much cheese. We'll see you when you get back.